Hi everyone, it's Tarulli Tutoring here. Today's video is about function notation, and I'm going to just jump right in and get started. Okay, so let's start off by learning what function notation is. For this next part here, I'm just going to be kind of reading off the screen, but then I'm going to go into examples later to illustrate my point, so just kind of listen, and then we'll do examples later. So, function notation, which is known as f of x, is used to represent the value of the dependent variable for a given value of the independent variable x. We have seen the use of the independent variable and the dependent variable in previous courses. The notation y and f of x are interchangeable in the equation of a graph or function. In other words, y is pretty much equal to f of x, and you will see this in the examples that we're going to do. The notation f of x is typically read as f at x or f of x. You can see from how I've been talking recently that I prefer to say f of x, but either is fine. The symbols f of x, g of x, and h of x are most commonly used to name the outputs of functions. However, other letters can also be used, such as v of t for the velocity as a function of time, and there'll be other things like h of t or whatever for like height as a function of time in other questions. Okay, so now that we've gone through some of the basic stuff, let's go and start doing some examples and reviewing. So like I said, y is equal to f of x. They're interchangeable. It's also very important to note that f of x is not f multiplied by the value of x. This is a mistake that people sometimes make because they see the brackets and they see f outside of it, and they think, oh, I'm multiplying x by f. No, that is not what it is. F represents the output value of a given function at a particular input value of x. So just to reiterate, f and x are not being multiplied by each other. We're saying that the function f has a certain value, output value, at a given x value, which is the input. Okay, just hope that we can get that straight. So going forward, we won't have any problems. I'm not going to see anyone in the comments being like, oh, is f being multiplied by x? No, it's not what's happening. Okay. Okay, now that we've covered that f of x is not f multiplied by x, let's do an example of how we would use function notation. So here on the screen, I've written out a simple equation of a parabola, y equals to x squared plus 4. And now I'm writing it out using function notation, which is f of x equals to x squared plus 4. We can see that these two equations are the same, except the bottom one is written with function notation. At this point, you might be wondering, well, if y equals to x squared plus 4 is the same as f of x equals to x squared plus 4, why am I using function notation at all? What purpose does this serve? And that's honestly a very good question. And I'm going to give you an example in the following slides to really illustrate why we use function notation and why it can be so important. So to illustrate this point, I am going to use the equation from before, y equals x squared plus 4, and I'm going to try to find the output value at the input value of x equals to 2. So doing this, I'm going to sub in 2 for x and input it into the equation. Doing so, I'll be squaring 2, so I'll get 4, and then I'm adding 4. So y will equal to 8, meaning my output value is 8. However, at this point, when we're looking at the end of the equation, we only see that y equals 8. We don't see anything else. We don't know what input value gave us this result. We just see that y equals 8. In our concluding statement, we don't know what the input value is. To illustrate how we would use function notation in this particular problem, let's go through the same problem using function notation. So say I wanted to find what the value of the equation f of x equals x squared plus 4 is at f of 2, or with an input value of 2, I would solve it like this. I would write f of 2 equals 2 squared plus 4. And I will go through the same steps. 2 squared equals 4, plus 4 is 8. So I know that my end result is f of 2 equals 8. However, what's interesting here isn't that we get the same result, it's that in our solution we know what the input and the output values are. We can see f of 2, 2 being our dependent variable, equals 8, which is our independent variable, thus telling us the coordinates of this particular point on the parabola is 2, 8. And that's what makes function notation so useful. Okay, now let's go through another example. Let's find the output value for the function f of x equals 2x squared plus 5 at the input point of f of negative 3. You can see that on the left side of the equation, I have written f of negative 3 instead of y, as we are now using function notation. And on the right side of the equation, I have put in the input value for x and I've substituted it normally, and I'm solving the equation. We know that negative 3 squared is 9, and then 2 times 9 is 18, plus 5 should give us a final answer of f of negative 3 will equal 23. Therefore, we know that our output value at the input value of negative 3 is 23. Furthermore, function notation allows us to determine that at this point, the coordinates on the graph are negative 3, 23. In the last two examples, we show the use of function notation for parabolas. However, you can use function notation for any function. And if you don't know what a function is, check out my last video where I explain what makes a relation a function. But now let's focus on finding the output value for the equation 1 over x minus 3 at the input value of f of 4. As you can see, I am going through and writing f of 4 on the left-hand side of the equation, and I am substituting 4 in for the value of x on the right side of the equation, and I am solving the equation as I would normally. I converted 3 to 12 over 4, so I can subtract fractions easily using the lowest common denominator, thus giving me an output value of negative 11 over 4. Furthermore, since we are using function notation, we can easily determine the coordinates of the graph at this point, which are 4 and negative 11 over 4. Okay, so now that we've gone through function notation and how to use it, try to go through these examples by yourself, pause the video here, and then once you've completed them, check back to see the solutions. Okay, here are the solutions step by step for each of the following practice questions. If you don't understand, try to go back previously in the video and rewatch and see where you could be messing up, or feel free to comment something down below and I will try and get back to you and explain where you may be messing up. Okay, so that concludes today's video on function notation. If you have any questions, feel free to comment below, like I said. If not, I will see you in the next video, and I hope that I was able to help you learn something new today.